We've been working together with HP for many, many years, and I did say HPE, formerly HP. And please give a warm welcome to our favorite partner, Arne Luhrs.
In actual fact, I should present myself a little bit different. Let me find this here. I think I have it. I think I should present myself like this. This was a couple of years ago. And this is actually how it started in HP. At that moment, still HP. We were going to revolutionize the way we were doing software. We're talking 2007, 2008. The picture is well before that. In 2013, we did something special. We took people out of normal operations and production and put them in a think tank. Now, which big company does that? Not many. We did it. It's all now open source. You can find that on GitHub. It's called the project Forge, F-O-R-J. It is essentially a way of setting up, I guess today we call that pipelines, CI/CD pipelines. So have a look at Forge, Forge-OSS, open source. So you will see what we did there. Essentially roll out a pipeline. Let's fast forward to the presentation. That way we get to where we want to be for today. It's going to be this one. And if I press this one, it will even work. My God, it works. What happens if I press here? Wow, it works. Let's look a little bit at reality. What is HP? HP is a huge company. HP at its height was 300,000 employees. Of course, sooner or later that goes overcritical, so we have split into HP Inc., HP Enterprise. For those of you who are following the news, you know that there is yet another split coming, whereby some of our outsourcing and our services part will be split out. But these are still the dates, the data that kind of reflects our internal environment. A little bit about me in all of this. I'm senior system architect in a corner that's called R&D IT. That's IT for R&D. So we deliver all IT services to all our R&D centers, and that's worldwide R&D centers. But we are also the IT R&D branch. As I said, the think tank, the people who reinvent the way how IT works internally. So without going into all these details, I mean, there is, I'm always overwhelmed if I look at them, just 900 projects that we have to follow. Millions of lines of code that change every day. The amount of servers, let me just give my little favorite application that I've been managing for the last couple of years. Quality Center, ALM Quality Center. Internally, that's 1,000 machines. That's 6 terabytes of data. That's 50,000 users spread out over the globe. The amount of test cases registered every day in there is in the millions. I mean, we essentially have a data overload problem, a big data problem in there. And we're managing that now in a DevOps way. Is that possible? Is it possible to manage SAP in a DevOps way? Yes, it is. Let's talk a little bit about that. First of all, what happens when we move from Agile to the next step on? We tried it with a couple of projects, and one of the first projects that we used was the internal fraud prevention program. I mean, as a big company, one of the things that we have is we have to look at the customer that buys from us. Okay, is he buying the right way? Does he get the right discount? Is he trying to get the discount that he is not entitled to? Is he trying to pay for something with something else? Is he trying to wiggle out under contracts, etc. He's using money that is not his money. Anyway, fraud prevention. Fraud prevention is a program that we use internally for finance. It is a banking application, and as was mentioned this morning, banking is typically one of those areas where, don't touch it, it works, this is sacred, this is money. Well, that means that you open windows between the deployments. Deployment once every 3 months, that means for 3 months you're exposed to problems. This moment in Devops, we're able to roll out deployments every day. We've gone from the original 12 weeks estimate for implementing new controls to less than 6 weeks, and actually we're at this moment down to about 3 weeks between a requirement and a rollout in production, knowing that rollouts in production can happen every day. The services split, or the splits that we're going through, this is an application that applies to all the HP entities. Normally, splitting out an application like that is horribly difficult. Well, just spin up another series of microservices, Kubernetes, thank you very much. Is exactly what we're using there. Simple. We've done in fiscal 15, 248 deployments. How many days are they in a year? 365 as far as I know. So it means we've done a deployment about every day for an application. That's banking for an application. That's critical. I'm not going to go through all the details. I mean, it just goes to show it really changes stuff. So let's take a step back. What is DevOps in our mind? Because DevOps is one of those things like, you put an elephant in the room, you put 10 blindfolded people in that same room, and you ask them to touch the subject that's there and to describe what they're feeling. If you haven't seen that image yet, look it up on the internet. It's one of the standard images about DevOps. It is such a big thing that everybody has its own concept of it. What is our concept of it? Our concept is it touches developments and operations. It is a system approach to Agile and Lean. If you look at it, what did Agile do for us? It broke down the wall between business requirements and developers. All of a sudden, the developers were allowed to talk to business, and there was a to and fro, a regular exchange, and not the 600 pages document that you mentioned? Or 6 years worth of development? No, it's just every day, let's exchange. But you got one problem. Development makes products like this, fast, all of a sudden. Operations, they have a very different agenda. My system runs, don't touch it. If you want to have a bug, install something new, it breaks. Oh, and by the way, just to make sure that you don't break it, you don't get access to it. Oh, and by the way, just to make sure that that is very controlled, we'll do that once a month. And oh yeah, it needs another 1 month lead time before you get your 1 month allowance to do so. So in other words, the requirement comes in, your development is done in a day, and then you sit for 1 to 2 months before something happens. A very simple example in our case happened that really brought for our management the message home that we had to change something. Every company has an internal store, HP as well. We have the HP shop, HP employee store. In actual fact, it's the same as a customer store. And in the customer store, one of the things that you have to do is you have to log in. So, there you go, enter your username, enter your password, and there's a big button underneath it, green button. You click on it, and the button turned red. Now, my reaction as a European, I know that the Japanese, the Chinese, the Asiatic room has a different reactions there, but our European expectation is something red is error. So you press the button, it turns red, so damn, wrong password. Username, this other password. Click. Red. Okay, which one was it? Red. Did you look at the rest of the screen? If you had looked at the rest of the screen, you would have seen that up in top right it said, please wait looking up your username. But you just saw the red button. So what do? You say, okay, well, I don't need this ink today, this printer, well, I can wait a month. You push out. You're not logging in, you're pushing out your request. We know the run rate of our HP store for employees. Seasonally corrected, etc. We know that we should be selling that much per month. This change is a simple change. It's a 2-liner, 3-liner CSS change. So its implementation is what? Minutes. Test, okay, let's test it. Manual, by the Indian team. There's time zone difference, okay. 1 day testing because of time zone difference. Deployment, okay. Malaysian team, manual deployment, another day. So, worst case, 3 days, we could have rolled this out in all the old methods. But what is the ops agenda? You shall not touch my system. You get a once a month chance with a 30-day lead time to enter all the paperwork to get your boat fixed. The result was, indeed, we had more or less 6 weeks lead time between fixing this 3-line code change. The loss in sales for the HP internal company store to HP employees was $1.4 million. Okay, that's internal sales, blah, blah, blah. It's $1.4 million. That's the moment when the think tank got created. That's the moment when we started to do DevOps. We did a meeting of all the lead architects of our internal applications and said, okay, what's wrong in our system? Why are we losing? What's the big problem? This picture as such is not interesting because I'm not in it. Sorry, wrong answer. This picture is interesting for one thing, is this young man up here, scratching his nose. Arne Luhrs, at that moment our Chief Information Technology Officer. He was supposed to come in just for a pep talk, first day, as all big C-level managers come. Hey team, great, start working together, looking for the output, I'll come back at the end of the week. This C-level executive stayed for the whole week in the meeting, working with us, going through us. This is how important this was deemed for us as a company. We spent 1 whole week hashing out the problems, seeing, okay, what are the processes that we have? What's hindering us at this moment? Yes, the famous 30-day RFC. Yes, the once-a-month release window, etc. And out of that, we came with manifesto. And this manifesto is really what has been driving us for the last 5 years now, as this is what we believe in, this is what we work from, this is what's guiding our DevOps. And let's take a step through it, because I think this is really important. First of all, we're looking at what's the goal. We're not going to be prescriptive about it, we're looking at what's the outcome that we're looking for. Which means that because we're not prescriptive, we're allowing ourselves to challenge all existing structures. So I will always come in and ask, why is this process there? Give me a valid explanation for this process. Why do we have an RFC process? Why? I'm painfully known for that. And the answer in the end is, yes, because we need control. Yes, because this. Yes, because that. Can we get it somehow else? And we'll come to that. All of our code is inner source by default. The comment was made that the best way of making sure that people use the right ways is templating code, having things that they can work from. Yes, all our code is inner source by default, because everybody is reinventing the same wheel. I have to touch a server, I have to set settings on a server. How many projects? 900 projects. How many development teams? 900 development teams. That means there's 900 different ways of touching a server. How about just having one library for doing that? Second, we have to do security audits of our systems. This big book of this is what you shall do, and then there is this black box test when you go into production, which means 2 months after you developed something, you get black box tests. The black box test comes back with an error. What did I develop 2 months ago? Hang on. I don't know. So what we're doing now, and that was a big step forward, all the test libraries, etc. CyberSec is now providing test libraries, not the book. They're providing code, inner source code. We've implemented GitHub Enterprise internally. We formulate hypotheses, we validate them with experience and data. Metrics, 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 metrics. Do I have to repeat it? Metrics. We measure, we look at it. Okay, we had a great dashboard that Wavy Code was showing. How many failures? How many deployments? How many rollouts? Exactly the same stuff that we did. How fast do things go through the system? How fast is it to bring up the system? Okay, you deployed something, it's wrong. Fine. How fast can you get it repaired? Mean time to recover of service. Those are metrics that we have. I'll come back to the metrics in the next slide. Resources are controlled by APIs and everything is code. Everything is code. Everything, everything, everything is code. Documentation is code. Infrastructure is code. Code, okay, that's code. Database is code. Database content, well, it's code. Which means we really have pushed, we really have pushed the envelope of saying everything is code to the extremes of saying we don't want Word documents anymore. It's simple markup documents in GitHub. We don't want videos anymore. You do whatever is possible to do it in GitHub in a tool that everybody can edit. Infrastructure, I'm just not going to CSA. I'm going to write the script in Ansible or whatever to talk directly to a CSA API or to talk to an OpenStack API. Did I say that we used Helium and OpenStack internally? So everything is code. And if we say everything is code, that also means code reviews. So I write code, I do a commit, and that automatically becomes a pull request in our GitHub internal. Pull requests are done and authorized into trunk only by a couple of people, the architects of the system globally. Where we can, we implement Gerrit, so that there is multiple reviewers, and you need to have a certain amount of reviewers who approve a code review before it goes through, and then into the automated build and deploy. And that's important because we've put into the line of approvers people from development, but also people from operations. So if I do a code change that does a DB change, my DBA has to prove as well and say, okay, this has no impact on the database, or my God, you're adding a table that's going to take that much more disk space. I have to do something on the DB before. All changes go through continuous delivery pipelines. I already mentioned that. And integrated, empowered, self-organizing teams. HP is big, so that means that for my applications that I have under my control, that's about 20 at this moment, I have development teams in Malaysia, I have operations teams in Malaysia, I've got development teams in China, I've got test team in India, I've got core developers in Mexico. I've got my co-architects in the US. Myself, I'm based in France. So we are definitely a wide team with a wide amount of managers. If I have to go through the management chain to talk to the team in Malaysia, Cyberjaya, to give me access to a system, it doesn't work. So we have virtually reorganized. I still have the same manager, but I have responsibilities along the software assets. So an end-to-end asset, which means the end-to-end notion of going from the software to the middleware, to the hardware, to the network infrastructure, to everything, is now one virtual team. So the software asset 116801, which is the internal asset number for ALM, has about 9 teams involved in operating it. These 9 teams work together as one team, self-organized, self-assigning, self-mingling. And in actual fact, our metrics have changed. At the end of the day, I'm not measured on, am I doing my work as a developer or as a senior architect? Or I'm evaluated on, is the application 116801 running at a certain level of uptime over the year? And everybody in the team is measured. This double metric changes a lot your behavior. And of course, we value trust and responsibility. Trust is very important in there because with trust comes root access to the systems or admin access to the systems. Did I just say root access to the systems, operational production systems? Yes, I did that. We have root access to operational systems, not as humans, as processes. My Ansible scripts can all do sudo, can all go directly to the system. But these Ansible scripts have been approved by all the people in the line because we do code reviews. And oh, by the way, these Ansible scripts are shared with the rest of the company because they're open source. You see how far this manifesto goes? For us, it's really, I wouldn't say the Bible, but it's very important. Something is making noise here. Is this the... Makes less noise. Okay, metrics, I said. The metrics that we used, Gartner has a great metrics pyramid. We are using part of it. I mean, you can start wherever you want. What we have started with is the points highlighted in red. So deployment success rate. You roll out a change. Does it work in production? How often does it go wrong? Do we have a 100% deployment success rate? No. We're at this moment in the upper 90s, which is fair. It's not what we want. I mean, essentially, we should have gone in our earlier testing, in the staging, the development, and in the staging environment through all the tests so that it doesn't run wrong into production. What goes wrong in production is usually we run into load issues. The famous ALM applications, the terabytes of data, we have run into Oracle bugs that even Oracle didn't know about. Just load related, which we couldn't simulate with the previous systems, the staging and development systems. The others that we use is cycle time and mean time to recovery. So cycle time, how long does it take from a requirement to go through the system to be rolled out? Which also means how good are you in getting the requirement broken in little tasks that you can roll out. So that is a very interesting metric because it really means that you have to think about what is the business asking me and can I do this task in one day? So usually what we try to do is a cycle time of 1 day. Mean time to recovery of service. Okay, I goofed, I rolled out a wrong version. How fast can I roll back to the previous version? Or in actual fact, we don't roll back, we roll forward. How fast can I correct the error that I've made? Can I do that with databases? Not always. So we do rollbacks occasionally, but the idea really is we're going to roll forward. Everything is always roll forward. We talked a lot about technology this morning, and my thinking was, yeah, technology is very important, but our internal assessment of what is really the problem with DevOps is 80% is culture, 20% is tools. Tools can make your life impossible, so you want to choose the right tools, but there's a lot of tools out there. What you want to do is use these tools that you've chosen to use in the right way, and that is culture. Hence the manifesto, hence all this layering around, you shall do things like code reviews. If you don't have a code review tool, code review is impossible. If you have a tool, but you don't have the culture to do it, then you have a problem. And typically, one of these culture elements, let's come back to code review as a sample, is we do code reviews every day. I've done them this morning in the hotel. Took me, for the 20 projects that are running with all the things that we have in flight, took me about an hour. It was a big day today. Normally it takes me about half an hour. It took me an hour this morning because there was a couple of big changes in flight. 20 projects, 1 hour code review. Nobody reacts on that. Means you don't do code reviews. Normally code reviews was measured by what the fuck per minute. Because you do code reviews of huge chunks of code. Because you don't understand what's going on. So the culture element here for code reviews has been, a code review shall never be bigger than one screen. If it fits on my screen, it's okay. Yes, but I'm going to implement a whole new API, it's going to be big, it's going to touch all. Well, implement it step by step. Stub it. Make me routines that will say, this routine will do that. Okay, I know you're going to think that. And that's wrong thinking, so I can tell you early that that stub is not necessary. So what we really are enforcing is a code review shall be so small, the changes that you commit, Git, are so small that everybody along the food chain can comprehend it. I can write Perl that nobody can understand. Does that make sense? Does it make sense to use Perl these days? It just shows my age, I'm sorry. No, it doesn't make sense to write code that nobody can read. I can be a very clever developer, but my ops guy has to read that code. My DB guy has to read that code. My networking guy, my infrastructure guy has to read that code. They have to understand what's happening. So my code changes shall be so small that everybody along the food chain can understand what is the change. So the culture change is really make it such that everybody can collaborate along the food chain so that everybody who does it can do that. And the side effect of that is, by the way, very interesting. As in every team, we have churn. As in every team, we've had people that have left. And one of the big moments that I had in the application that we'll be using for testing the whole process was I lost my UI developer. Mexico, Bam Bam as his nickname was, Edgardo Campos. Edgardo is one of those guys who code, I mean, you just can't imagine. He really understands the UI, he really has good ideas, he's got the creative spirit, he's got the artistic touch, and he writes code that is beautiful. So you tell him, I'm on a new layout for this page, with the button here, etc. He will come an hour later with what you think is a mock-up, but in reality is already functioning code. And he will have made a couple of changes because he thinks that this is more aesthetically pleasing, etc. One of these rare developers. Of course he leaves to do a startup. Of course he's successful and very happy at this moment. Guadalajara has a new company doing software development for UI. But I don't have that developer anymore. So you as a team leader, what do you say? Okay, damn, I have to hire a new guy. Shit, Okay, who knows Node.js? Who knows Spring? Who knows this? Who knows that? Oh, and by the way, he was doing Gromit at this moment. Black 7-legged sheep with white tail. The funny thing was, internally in the Mexican team, because everybody had been doing peer reviews of code and we had the code review system, two of the Mexican developers said, hey, can we give it a try? Tell you what, we had 1 week production loss. 1 week, the time it took for one of the two to really stand up and say, okay, now I got it under control. Do we have the same creativity as before? No. Did we need all the creativity and the aesthetically pleasing layout? Well, we've got a couple of other people who can help with that. Peer review had given us the possibility for everybody to understand the code, to know what was the philosophy behind the code, and to do the right thing. Have you tried to manage developers? Are you a developer? If you're a developer, you know that the greatest newest tool is always the most attractive. Have you tried to manage developers? You know that developers go like, it's like herding cats. It goes all over the place. If you do peer reviews, if you do code reviews, you can very, very early in the process say, okay, great library, I don't think we're going to use it. Great idea, doesn't fit in the philosophy of what we're trying to do. Great idea, but this is hard-coded. Maybe you want to change this, etc. And all of a sudden, with very little touches, the way that you're driving a car, you're not doing this. You're doing almost imperceptible changes. You keep the whole team on track. Because every day, every morning, I do my code review, I give my comments where I say, okay, great stuff, looks good to me, do merge, or hang on, this is hard-coded, or hang on, this and that and that and that. You get a great control over what you're doing. So, what is different, really, in everything that we're doing? I'll go through these four, and by that time that we've done these four, we're done. Just to give you a heads up. From a command and control system, we got to integrated and empowered. It really is, we've put trust above control, over control. We're working on what we call the minimum viable process. Or to say it better for a seafaring nation, we put buoys there which indicate the main navigation channel, not the boundaries. We indicate the center line. Because as a software developer, software has one great thing. It is not mechanical engineering. It is not Taylorism. Software is flexible. So why do you want to remove flexibility from software by putting outer boundaries on it? No. People need to experiment. People need to try new stuff. But you want to give them that guiding line. So we put buoys there saying, this is where we're heading. If you have a new library that does the same stuff, use it. We trust you that you implement the right thing. We put in place what we call the minimum viable process, not controls everywhere, but trust everywhere, but we give a guiding line where to go. From the request of change, we go to a change control process, change records and audits. So what are we doing? Why is there a request for change process? What is the purpose? The famous why? A request for change is a way to have audit records that the right person at the right moment did the right tests, touched the right system, and that people who were not authorized did not touch the system. So an RFC essentially is nothing but generating audit logs. The right person at the right moment touched the right system. A developer touched the dev system, only an ops person touched production systems, etc. But a request for change that contains instruction on how to roll out something which are being rolled out manually, and a request for change that needs approval from everybody, and it's just a paper trail that lasts for 30 days, a request for change that stands in the way of rolling out a fix for a blatant zero-day bug, that's not what you want. So, change records are now logging what they're doing in a delivery pipeline. So rather than say, okay, it's a human that touches the system, no, it's a process that touches the system, but the process has logs. These logs are logged. And in actual fact, all the request for change checking, you do that automated. Are we rolling out something to a production system that is under freeze for financial closure? Well, if you can look it up in spreadsheet, then a process should be able to look it up in a spreadsheet, and that process should say, okay, I'm sorry, your change is approved, but I cannot roll out because we're in freeze period. So why go through manual processes? Go through automation. Secondly, yes, we do request for changes so that everybody who does support of the systems does know that somebody has touched the system. Okay, how many systems do we have? How many did I say for ALM? Okay, it's one application, so it's a limited amount of users. It's a limited amount of changes that you do on that. I've got 20 people in India doing support for ALM. They're working 24/7, and it's not the only application that they support. Are they going to look in an RFC to see if that system has been touched? No, so it doesn't work. However, a change log, if they go on the system and automatically it says that change log has happened. It's very clear. Was that change log tested? Yes. Did it fail in staging or development? No. Does it fail in production? Yes. Oh. Well, in Hekjavik is a user failure. They forgot that they had to upgrade the client. Okay. So, change records, we at this moment really have moved away from RFC. So people who implement internally a complete CI/CD pipeline are liberated from the RFC process. If you want to continue the good old waterfall and RFC process, fine. If you think your application justifies it, like the fraud detection application, they thought it justified it to do it a very controlled way. We convinced them that this gave them better results. You've seen the results in the beginning. Mostly manual automation in dev test only. Everything is code. I cannot repeat that enough. Everything is code. We know that code is code. Already talked about code reviews, but I really want to stress the fact that deployment is code. I really want to stress the fact that creating a new server is code. I want to have a new environment. Kube control app, Docker machine create, Ansible create, Nova boot. For those of you who are developers, you just recognized a couple of ways of starting systems from scratch. And that is code. And that code has been seen by a lot of people. So these people will say, okay, hang on. Your Docker Compose here is asking for 25 servers, but we only have one Docker host running that. 25, we're going to have to add at least some memory. Or maybe better, make a swarm out of it. Or maybe better go onto the cluster. So the fact that you're asking for new hardware, how was that done before? I entered a request for hardware. Okay, I'll have to rack a system, have to order systems, etc. I mean, we went from a ordering of new hardware every 6 months with about the same problems that you get whenever there's a long wait time like that. You're going to order 10 more just to be on the safe side, to less than 18 hours for complete new systems. So that really changes if everything is code, because everybody sees, hey, this is coming. Because you know that, oh, in dev we're asking that already. Environment is code, configuration changes is code, the proxy change, the re-IP that we go through the split at this moment. You're not going to manually touch thousands of systems. A patch update to my ALM base. Did I say that it was 1,000 servers? Do you see me go to 1,000 servers and do on 1,000 ALM install minus silent? Oh damn, I forgot to copy the binary. Redo. Those installs last for about 25 minutes. Ansible to the rescue. Or Puppet. Data, infrastructure, well, everything goes through the delivery pipeline. Continuous delivery pipeline. Interesting to note down there is the icons. It's not the delivery pipeline. I mean, we have talked enough about pipelines already. Interesting down there is to know that changes move rapidly through, but also that we use various different tools, and you recognize in there a lot of things that are open source. It is not because we are HP that we're only using our own tools. It's not because we're HP that we are able to spend money on everything everywhere. Electric Commander, great product, we're using it. We're going to replace it massively by Jenkins because Electric Commander is a license that's prohibitive. Oracle, we're using it massively. We have a lawsuit between Oracle and HP, so we're at this moment massively moving to other database solutions. Did I say that MySQL Appertain was also Oracle influenced? We have a problem there. The important thing in the delivery pipeline is not how fast can you get through it, but how fast can you get this feedback. And guess what? The fact that we have pipelines at this moment really have changed behavior, once again a cultural change in our developers. They are now doing experimental development. Why should they have the whole development on their laptop? If they do a code commit, it triggers automatically the build chain. The build chain starts with lint of their code, syntax checking of their code. Oh damn, I forgot semicolon. My Jenkins just failed, but it failed fast. And in actual fact, our discussions in the architectural board is what is the level of testing, what are the layers of testing that we're doing at this moment so that the developer has feedback within, and that's where the discussion lies, within 5 minutes, within 3 minutes, definitely not within quarter of an hour, but because within quarter of an hour you've already done so many other things. So the first level of tests have to go very fast. And actually we have come to the point at this moment that a lot of people now do experimental. They just add little routines, they change, etc. because the feedback is so instantaneous. And because they can do it from any terminal. I'm not going to do it on an iPhone, that's too small. But I've done it on an iPad, that's feasible, although I don't like the fact that it's a touch keyboard. I really do prefer normal keyboards. Did I say I had a development environment with me? No. I had a terminal with me. We have come to that point where indeed developers are at this moment able to do a lot of stuff with very limited means because they get feedback fast. And we've got level 1 testing, which really is the fast testing, level 2, 3, 4 testing. And I invite you to read Agile in the Enterprise, the story of the HP LaserJet, which lays out very well how that was done on the firmware of the HP LaserJet. I really invite you to read that. It's a very, very good book. There's another book I'm going to reference at the end, which is a management overview of the same thing. Did I say we do everything as code, infrastructure as a code, and a lot of open source? I mean, you will recognize a lot of those. Emails and ticket handsovers, and this is the big aha, and I will need a couple of minutes for that one. Because this is really the change. The real change is the implementation of what we call ChatOps. So ChatOps is chat, as was mentioned. Yes, we're chatting. Yes, we use tools for chatting because that's the best way without a reorganization to federate a team around one asset. Well, we've added intelligence to it. We've added the intelligence of robots to it. So we're using Hubbot, and I can say in a chat room, Hubbot, deploy new version. Or Hubbard, give me the stats for the application. Or Hubbard, give me information. It's all in the same chat room. Everybody in that chat room is informed that there is a new deployment. The robot knows that only authorized people are allowed to do it. So ChatOps really has enabled us in a worldwide company to break down the barriers of organization, to break down the barriers of time zone, and to go really to the point of working together as a team on an application. So where are we now? We're scaling up. We've gone way beyond the unicorn, we've gone way beyond the prototype. At this moment we're rolling it out with things that we call the Devops Academy, with the Devops dojos. Some of that we have productized. It's also products that at this moment we present to our customers. The transformation workshops to get everybody to understand what is DevOps culture, to understand where the problems lie. So the first week that we did of assessment, we've translated that in our transformation workshops. And the DevOps Dojo is the 1 week hackathon with one team, guided by a couple of the DevOps leads. You come with your program internally. You build your pipeline in the hackathon. You're gonna solve problems in the hackathon on your application. Really very, very powerful. We run them internally about twice a month at different places. My next one is due end of this month, and we run them at this moment also with customers. I said I was going to talk about a couple of books. This is the last slide. I know that you've heard about the Phoenix Project. Read it, it's fun read. It definitely gets you around the lingo and the thoughts about DevOps. It's a fun read. Continuous delivery. Buy a box of aspirin before you read it. It's one of those reference books. You put it on your table and you go regularly through it because it has a couple of very interesting concepts. Do not try to read it front to back. You will need aspirin. A book I recommend definitely for management is Leading the Transformation. It's the summarized version of the LaserJet firmware story. It's essentially what does it take to move from a waterfall or maybe agile-based environment to move over to a really DevOps environment. What are the changes? What are the cultural changes? It's I would hesitate to say it's a C-level or a corporate management level book. It goes wider than that. For a developer, it's interesting to know what your manager is going to tell you. And with that, thank you very much. Questions, if any? I'm around till about lunchtime. My flight is at 3, going back to Paris, going back to Grenoble. Yes, please.
Yep. Do you use Ansible for managing the infrastructure, or are you using Terraform or any sort cloud, or what software for managing the actual infrastructure?
We have mixed infrastructure, so we have lots of legacy stuff. We've got a lot of modern stuff. For the legacy stuff, we are usually using CSA, Cloud Service Automation, because that allows us to abstract the VMware that's underneath, plus the real hardware that's underneath. For the more modern stuff, we tend to use Helion OpenStack, and essentially at this moment we even expose it directly, so people can use the Nova API, the OpenStack APIs directly. They will have tenants with resource limitation. After that, they are free to use whatever. So to use Terraform, to use Ansible, to use fog libraries or any. Vagrant, we use a lot of HashiCorp stuff in there. Terraform is HashiCorp. We use a little bit of PaaS, so Staccato environments. We use it a little bit. It's not entirely conclusive. We have applications that run there. It's not entirely conclusive, but that's more the type of legacy applications that we are dealing with. We're using a lot of Docker. We've got a lot of push with Docker in a data center, the Docker Unified Control Panel, as proposed by Docker, is a collaboration that we have, very active collaboration that we have with Docker. And as mentioned before, we use Kubernetes a lot. So we go pretty wide in the scale, and a lot of it depends on whether it's a legacy application or whether it's really a new microservice-oriented application. Please.
You say that you use Docker, and of course, I would like to know if you use Docker up to the HP Alien or something like that, or directly on the bare metal, directly on the hardware, because you know about the latency problems and
Yeah.
the problem about the overhead, whatever.
Sure.
It's quite
We use a couple of implementations of Docker. One, there is the Magnum project that we use, so which is OpenStack or Kubernetes on top of OpenStack. That we use a lot because very simply it gives people the possibility to create and destroy fast. Plus it creates the underlying virtual hardware. And it still gives us the abstraction at our infrastructure group to put up servers and to do the resource management, the resource pre-allocation, depending on demand that's coming in. Yes, it has a disadvantage of latency. We also have, now that we have the Synergy platform, we're using a lot of bare metal Docker installations. So we install on the Synergy platform, which is a hyper-converged platform. There we install directly machines with Docker machine installed on it. They are grouped together as swarms with universal control panel. So at that moment, we use both.
Yeah.
We use both.
not for production environment or only for developers.
For production, we are using at this moment both.
Okay.
We've got both in production. Public facing, we have Kubernetes. But that's only because the Synergy platform is a little bit younger and we haven't yet found the right sponsor to buy the hardware.
Yeah.
So we're using that more too.
Thank you very much. I need to tell you we need to keep the questions for the panel discussion. Otherwise, our last speaker will not get his well-deserved time. So thank you very much, Arne, once again.